Storybox Audio.
Please like this video and subscribe. So today we'll be looking at calculus power rule. So we are going to look at more example on power rule. So what we are going to do now, we are going to take a look at what we call power rule. So if we have y equal to ax having power of n, therefore the power rule says dy over dx will equal to, so therefore dy over dx will equal to the power will multiply the function, so that we're having ax into power of n, then we subtract minus 1 to the power. So this is what we call power rule. So we are going to look at some example. Example 1. If y equal to 10x square plus x minus 15, then we are told to find dy over dx. To find dy over dx, what we need to do is that we need to differentiate with respect to x, and we can see that when we are having constant, due to our previous video, we know that constant is always equal to 0. So when we differentiate with respect to x, the difference in y over the difference in x, the 2, which is the power, will multiply the function, which is 10x squared, then we subtract minus 1 to the power, plus this is having power of 1, so that when the 1 multiply the function, then we subtract minus 1 to it, so our constant will give us 0, so that dy over dx will equal to 20x plus 1. So to get our 1 minus 1 will give us 0. X having power of 0 will equal to 1, so that when 1 should multiply each other, we have 1. So dy over dx equal to 1. So let's look at example 2. Example 2. If y equal to root x plus 2, and we are told to find dy over dx. To find dy over dx, what we need to do is, I'm going to try to rewrite this expression. So when we rewrite it, we all know that this is still the same thing as x having power of half, which means anytime we are having root, we can write it as having power of half plus 2. This is a constant, is already gone because it will be giving us 0. So when we differentiate with respect to x, we'll be having dy over dx will equal to the power will multiply the function, then we'll be having x into half, then we subtract minus 1, so that dy over dx will equal to half times, when we solve this, we'll be having minus half, so that we can see that when we have 1 over 2 minus 1 over 1 LCM 2, that will give us 1 minus 2, and which will give us minus 1 over 2. So from here, dy, what we need to do now, we need to rewrite this, so that we're having dy over dx will equal to half times this minus is still the same thing as 1 over x having power of half, so that we'll be having dy over dx will equal to half times 1 over, then we write this into this, so that we can see from the beginning this is equal to this, so that we can rewrite it, so that from here we can say our dy over dx will equal to 1 we multiply 1, that's 1 over root x. So dy over dx is 1 over root x. So example 3, we are given if y if y equal to 5 over x and we are told to find the y over the x, I'm going to try to explain this. We need to rewrite it. We all know that this is still the same thing as 5 times 1 over x. This will multiply this and give us this, so that from here we can rewrite this expression into this 5 times x having power of 1. 1 over is still the same thing as having power of 1. So from here we differentiate. When we differentiate with respect to x, the difference in y over the difference in x will equal to 5 times the minus 1 we multiply, which is the power, we multiply the function, then we subtract minus 1 to the power. So from here the y over the x will equal to, when this multiply, we are having minus 5 times x into minus 2, minus 1 minus 1 minus 2, so that the y over the x will equal to minus 5 times minus in indices is 1 over x square. So from here the y over the x will equal to this minus 5 will multiply, so that we are having minus 5 over x square. So the y over the x is minus 5 over x square. Thank you.